you get confused. So any type of function, linears, quadratics, exponentials, polynomials, can be considered even or odd functions. Okay? So this applies to all functions. Whereas the degree stuff that we've been talking about, even versus odd degree, only applies to polynomials. And not only that, but even an odd degree applying to polynomials talks about end behavior. It gives us insight as to, does the polynomial open up or open down on the end behavior, or does it start low, end high, or start high, end low if it's an odd degree. That's all degree stuff and only applies to polynomials, whereas what we're about to do, which is even and odd functions, applies to all functions. Not only that, but if you are a polynomial, you have to be categorized as even degree or odd degree. Whereas if you're any regular function, you could be an even function, you could be an odd function, or you could be neither type. You could be neither even nor odd. You can't, if you're a polynomial, you can't say, oh, it's not even degreed and it's not odd degreed. It has to be one or the other. Not true with basic, just even odd functions. So that's the first thing to know, is that there are two things here that are, they're concepts that do have a relationship somewhere in there, but it's not very straightforward, so we're just going to treat them as two totally separate concepts. So with functions, there's a visual way to check, which is probably the easiest. And then there's an algebraic way to check, which you might be forced to use if it says, show your work algebraically. So you have to know both. The visual way is based on symmetry. If a function is even, it will be symmetrical to the y-axis. So for example, that's even, because here's your y-axis, and if you reflected that shape over the y-axis, it would land on top of itself. Odd functions are symmetrical to the origin, and what that means is that if you flipped it upside down, it will look the same. So for example, back graph. See how that starts in quadrant 3 and kind of wiggles through the origin and ends up in quadrant 1? If I flip it upside down, it's still starting in quadrant 3, wiggling through the origin, and ending in quadrant 1. So that's what being symmetrical to the origin is if you look the same right side up as you do, like identical right side up as you do upside down. So that's the visual test, and you can always just take any formula, any function, put it into your calculator and look at it. And if it's not perfectly symmetrical to either, then you would say neither. So there's a gazillion graphs that are neither. Like if I just even moved my quadratic over a little bit, that's not symmetrical to either, right? If I flip that over the y-axis, it's a totally different shape. Right now it's in the second quadrant. If I flip it upside down, it's in the fourth quadrant. So it's a totally different shape. So this one would be a neither. The algebraic test is this. You plug in negative x. No matter what, plug in negative x and simplify. If when you simplify, you get back the original equation, it's even. If you get back a negative version of the original equation, it's odd. If you get back something different that's just not the exact opposite, then it's neither. So the notation here shows here you are plugging in negative x, and when you simplify it, you get back the original f of x function. Here you are plugging in negative x, and you get back a negative version of the original function. Okay, so these examples below we're going to do algebraically first, and then we'll use the calculator to also confirm that. So you always plug in negative x. So if I plug in negative x and simplify that, is that the same as the original? Is the absolute value of negative x the same as the absolute value of x? Yes. So that gives you the original exactly, so that's even. Therefore, when I graph it, it should be symmetrical to what? The y-axis. Do you guys know what absolute value parent graphs look like? Yep. And this particular one is shifted how? 4 down. So can't you see that it's still going to be symmetrical to the y-axis if you've shifted it 4 down? Here it is on your graph. Right? We all agree. Symmetrical to the y-axis. So it's even. Good? This is an x cubed. It didn't read well, but if I plug in negative x, I'm going to get negative x cubed minus 4 times negative x. When I cube negative x, what do I get? Jason? Yeah, to the third power though, right? Negative x times negative x times negative x is going to be negative x to the third power. And what's this going to be, Jason? Plus 4x. Is that exactly the same as the original? No. Is it the opposite of the original? A negated version of the original would be like putting a negative out in front. So if I were to put a negative out in front, the opposite version of the original, if I distribute that negative, should look like negative x cubed plus 4x. Is that what I have? Yes. So this is odd. Now, here's the graph of it. Right side up. Starts in the third, goes up to the second, dips down to the fourth, and ends in the first. If I flip my calculator upside down, exact same graph. Yes? So right side up, upside down looks the same, symmetrical to the origin, odd. Okay? Plug in negative x here, I get 1 over negative x squared minus 2 times negative x plus 3. When I simplify that, 1 over, what is negative x, Alexa, when you square it going to be? Just plain x? X squared, good. Next term, Angie? Good. And then plus 3. Is that exactly the same as the original? Is that the exact opposite of the original? Okay, side question. What would the exact opposite of a fraction look like? How do you, first of all, how do you take the opposite of a fraction? Let's just take 2/3. What's the opposite of 2/3? No, that's the reciprocal. Opposite means you negate. The opposite of 5 is negative 5. The reciprocal of 5 is 1/5. Are we good with that? So don't confuse, you guys get those confused a lot because of opposite reciprocals in like perpendicular slopes where you negate it and you flip it. Opposite means negate, reciprocal means flip. So a negated version of 2/3 could be written one of 3 ways. or you could just negate the denominator, or you could throw a negative sign up in front of the fraction. Yes? You definitely do not negate both of them, right? Because negative 2 over negative 3 would be what? Positive 2/3. And is that the opposite of 2/3? No, same thing. You negate both. You've essentially multiplied by negative 1 over negative 1, so you change the appearance, but you didn't change the value, right? So if you are to negate 3, what it would look like if it was a negated version, it would either be negative 1 over the same denominator, or you keep the numerator the same and negate the denominator. And when the denominator is a polynomial, negating it means you're flipping every single time, right? Negative version of the denominator would look like that. Okay? So if we got this or if we got this, we would consider that a negative version of the original. Did we get either of those? No. So it's not exactly the same. It's not an opposite version of the original. Therefore, this function is neither even nor opposite. Okay? Part of the thing with odds is knowing what to expect. Knowing how to negate things, especially fractions we struggle with. And if you were to look at that graph, you would not see symmetry with the y-axis, and you would not see symmetry with the origin. Okay, if I plug negative x into this one, that's going to simplify to negative x over negative x cubed minus x. What do you think about this? Even, odd, or neither? We're going to take a vote. Even, hold up the number 1. Odd, hold up the number 2. Neither, hold up the number 3. Not yet. Think about it. Even will be 1. Odd will be 2. Neither will be 3. On your mark, get set, go. Ooh, we're all over the place. All over the place. Okay. I will tell you it is even. If it was odd, only this would be negative x over the same denominator, or it would be still an x over a negative x cubed minus x. Only the numerator would be negated, or only the denominator would be negated. Both of them are negated. So really what we could do here is we could factor a negative 1 out of the x, it's not really factoring, and factor a negative 1 out of the denominator, and your double negatives would cancel. I put a cubed, squared, not a cubed. And then you have the same as the original. We just did this with the 2/3. If you negate the numerator and the denominator, you're looking at the same thing, right? 2/3 versus negative 2 over negative 3 is the same thing. And so this was even. How do you negate a radical? Let's just do a numerical example quick. If I do 3 root 4, oh, that's bad because 4 is 3 root 3. What's the opposite of 3 root 3? If on a number line, here's 0, 3 root 3 is here, what's on the opposite side of 0? Negative 3 root 3. So you just would see a negative out in front. Nothing would change about what's underneath if we expect a negative. So we're going to test this algebraically, plug in a negative x. Simplify. There's really no simplifying. Is this exactly the same as the original? No, so not even. Is it the exact opposite of the original? No, so this is neither. And lastly, in 6, if I plug in a negative x, And simplify, negative x when I square it is just going to be x squared. Is that exactly the same as the original? Yes, so that's even. If I looked at that image, that would be symmetrical to the y-axis. That would be an interesting one to see. I don't think you've ever seen a graph like this before. Yes, we all can agree, though, that it's symmetrical to the y-axis. Okay. In the next exercise, it gives us only a partial graph of a function. And it shows us the 3 points that they connected. So there's 0, 0, there's 3, 5, and there's 7, negative 2. Sketch the other half if it's an even function. So if this is even, and we flip this to get the other half of the graph over the y-axis, 3, 5 is now going to be where? If I flip this over, negative, say it again, negative 3, 5. If you flip over the y-axis, you negate the x. And 7, negative 2 is going to flip over to be negative 7, negative 2. And 0, 0 is already on the y-axis, so it stays the same. Same partial graph in B, but they want it to be symmetrical to the origin. So essentially this here, when I flip it upside down, it's currently 3, 5. When I flip it upside down, what are the coordinates of that? Right. And so from there, you should be able to come up with a rule. What's the rule? To flip a point over the origin. Flip both signs. So 7, negative 2 would become negative 7, positive 2. So just do those. And you've got an odd function that looks the same right side up as it does upside down. Good? Any questions? Let's see. Oh, we got lots of great questions on the back. What to choose from with my 2 minutes? Let's start with this one. If f of x is an odd and one-to-one, and I'm starting with that because we haven't talked about one-to-one in a while. A one-to-one function is something that x's don't repeat and y coordinates don't repeat, right? It's something that passes the horizontal line test and the vertical line test. This should be a flashcard because this has been a long time that we've even discussed this. You probably forgot about it. So f of x is an odd function with 5, negative 2. Let's first start by talking about the odd part. Based on what we just did on the other side, if 5, negative 2 is on the graph, what other point is on the graph if it's an odd function? Right. So that's the original function, right? They're asking us which point must lie on the graph of its inverse. How do you find the inverse of points? Switch the x and the y. So negative 2, 5 is definitely on the inverse. And 2, negative 5 is definitely on the inverse function. So what's the answer? 2. Of course, they wouldn't both be options because they would be right. So that one's interesting because they play into your understanding of odd and they play into your understanding of inverses. You take one pass down. Can we thread this around like down, back, down, back? Nope, that's not what I meant. Although that will work too. This will be faster. you pass out the whole stack, Alexa's going to pass to Andy all the way down, and then you're going to go back and it's going to come all the way down.
Oh my god.
And then she's going to go back, and then it's going to go like that.
Are you kidding me?
We don't get partners.